I've chosen this as example 2 because it's a little bit different and if you to the previous example. And if you haven't had a good look at this question and have an understanding of the diagram, then please pause the video now and do that before you see me start to talk about the solution. So hopefully you realise that there are 4 triangles in all. There are 3 of them which are, no, 2 of them which are right angled. There's this one triangle A, B, C that seems to be flat on the ground, that is not right angled. And then this triangle B to A to D, that triangle that's on a slope, and that wouldn't be right angled either. But the triangle D to C to A is definitely right angled, and the triangle D, C to B is definitely right angled. So the situation is this pole is coming out from the ground. The ground is, along the ground is the distance A to C, which would obviously be at right angles to a vertical pole, and C to B also runs along the ground, and that is perpendicular to a vertical pole. Okay, let's have a look at A. Find how far A is from the foot of the pole to the nearest degree. So, to the nearest metre. So, how far A is this distance here, A to C. Might redraw that triangle. So when I've redrawn it, it's a bit more obvious that we don't have very much information within this triangle. A to C, I've just labelled that X, and that's what we're asked to find, the distance of A from the base of the pole. We know the angle from A up to D is 58, and we know this is a right angle. Now, like I said, that's not enough. We don't have enough information about the sides to continue on with that triangle. We do have some other information in the diagram, and in particular, we look at a triangle ABC. And again, by you actually redrawing that out, you should realise that that is not a right angle triangle. It's certainly, well, you may initially have thought that the angle down in here was going to be 90, but obviously with these two adding to 86, then you can see this has to be 94 in here to add to 180, and it's not right angled. So what we do have here are an unknown side, a given side, and we've got all 3 angles. Now in that situation, in a non-right angle triangle, we could use the sine rule actually to find the length of x. And you can see that x would then be 100 times sine 34 divided by sine 94. Using your calculator, you can see that is 56.0558, etc. We were asked to give it to the nearest metre, and so we would write 56 metres. Once we've got the value of x, it makes the solution for B quite straightforward. We're back in a right angle triangle. We want the height of the pole. We've got an angle and an adjacent side, and we want the opposite side, opposite to that, over the adjacent, and actually the dimension A to D is the hypotenuse. In this case, it's opposite the right angle. So again, we're going to use tan and solve our equation for D to C, which I might label Y. And so tan 58 is Y over 56, because that's a value for X. Y is 56 tan 58. You can see that's 89.61873363, and it's said to 1 dp, and the height of the pole. Therefore, the height of the pole is 89.6 metres to 1 dp.